So the second part of the bell work was to graph the function rule. So f of x is equal to x plus 3. Okay, so whenever I'm graphing this, this is like having y equals x plus 3. So if I'm going to graph this, I'm going to start with the y-intercept, which is 3. Okay, and then my slope is the number in front of x, which is like 1 or 1 over 1. Whoops, forgot to share my screen back to you guys. Hold on. Sorry. A lot of stuff going on here. Okay, so y equals 1x plus 3. Okay, so started at 3, which is what you see here. Okay, my slope is 1 over 1, so I'm going to go up 1 and to the right 1 as many times as I want to, and that is going to make my graph. Okay, so those are the two things you should get on your bell work. Okay, the way that I graph this is what we're going to talk about today. Okay, you would have got this same thing. You would have got this same thing if you would have made a chart with a couple numbers here. So 0, 1, -1, and so on. You could have got 3, 4, and 2. You would have got the same graph. Okay, you would have got the same y-intercept right here. Okay, and you would have found the same slope along the way. Okay, so that's what your graph should look like, and that is what your ordered pair should look like. Okay, any questions so far? Okay, if you guys have a question, just unmute yourself. If you guys have a question, you can just ask, okay? Okay, so in section 5.1, okay, so you might want to write some of these things down as we go. If you don't have a copy of these notes, obviously, I will have them posted for you, but you will want to write some of these things down so you can use it for your homework, okay? So we're going to be finding rates of change from tables and also finding slope, okay? So you can use ratios to show that what a relationship is between a vertical and horizontal change, or the x and the y's. Rate of change, this shows the relationship between two changing quantities. Okay, so how fast or how slow is something changing? When one quantity depends on the other, the following is true. Okay, so rate of change is always the change in the dependent variable over the change of the independent variable. So the change in the dependent variable, the dependent one, is always going to be the y variable. Okay, the independent variable is always going to be the x. Okay. So the change in y over the change in x. Okay. That's what we're going to be looking at here. So we are going to be looking at a table, and we are going to figure out what the rate of change is. Okay, so it says the table shows the distance a band marches over time. Is there a rate of change in the distance with respect to the constant, or a time constant, sorry. What does the rate of change represent? Okay. So we're looking for the rate of change, or the change in the distance over the change in the time, because this is like x and this is like y, okay? So distance is representing y, time is representing the x, okay? So whenever I'm looking at my change, okay, I've got y over x, or 260 over 1, okay? If I simplify that, it's just going to be 260, okay? If I look at the second one, after 2 minutes, they've gone 520 feet, okay? That's going to be 520 y over x, 2. If I simplify that, I also get 260, okay? Then I'm going to look at these two. If I do y over x, or distance over time, I'm going to have 780 over 3 minutes, okay? If I simplify, or if I reduce that like it's a fraction, 780 over 3, I also get 260. Okay, and then for the last one here, after 4 minutes, they've gone 1,040 feet. Again, if I reduce that like it's a fraction, I'm going to get 260. Okay, so if you have your calculator at home, or if you have a calculator, okay, you can type this in like a fraction and it'll reduce it. So you guys, I think, have the same calculator. Okay, so you can reduce these fractions like that. You can also just do regular division. Okay, so if I do 780 divided by 3, I'll get 260. Okay, so since this is a constant rate of change, every single time we're getting 260. Okay, that is the rate of change. Okay, now it's also asking you what that represents. Okay, so the time that went on, okay, it went up a minute every single time. Okay, the distance went up by 260 every single time. Okay, so that means every minute the band marches 260 feet. Okay, so every minute the band marches 260 feet, or 260 feet per minute. Okay. Any questions about finding the rate of change? You guys? Okay, so the main thing to remember for rate of change is that it's always going to be y over x, not x over y, not like alphabetical. It's always y over x. So how are the y's compared to the x's? Okay, and it's always a fraction like that. Now, we're going to talk a little bit about slope. Okay, so slope is going to be present a lot in this chapter. It's going to be in every graph that we are looking at. Okay, so slope is the rate of change, but for a line. Okay, so slope would be like the vertical change over the horizontal change. Again, the vertical one that runs straight up and down like this, that's the y. Okay, horizontal change runs left to right like this, that's the x. So that is not changing. It's still going to be y over x. Okay, we like to call this rise over run. Is that anything you guys have heard before? Okay, so rise over run, how are you rising, or how is y changing? And how are you running, or how is x changing? Okay, so we are going to find the slope of this line that they've given us here. Okay, for us to find the slope, we're going to find some points on our line. Okay, so I'm going to say there is a point right here. There's a point right here. And there's actually one down here. Okay, so you got a couple of different options where you can see where it's crossing on the grid. Okay, so if I'm going to find the slope of my line, I'm going to figure out how do I get from one point to the next, okay, or how do I do rise over run, or how do I move on my graph. Okay, so I'm going to use these 2 points right here. I'm going to try to figure out how many places do I have to go up and over to get to that next point. Okay, I'm going uphill. Okay, so if I'm finding my slope, okay, I need rise over run, so I need my y over my x. Okay, so if I'm starting at this point down here and I'm going up, okay, I go up 1, 2 units. Okay, and since I'm going up, that's a positive number. Okay, so it's positive 2. Okay, when I'm moving to the right, going towards the positive numbers on the x, 1, 2, 3. Okay, that's a positive 3 because I'm going towards the positive numbers on the x-axis. Okay, so my rate of change, anytime that I can reduce it, okay, I need to reduce it. If this is not reduced in this case, then that just means your slope is 2 over 3. Okay. Any questions? Okay. So we're going to practice finding slope a little bit. Okay, anytime that we move up or to the right, that's always going to be a positive number that we're using for our slope. Okay, so if you want to write that down, it's easy to remember. Okay, that's because the top part of the number line for y, if I'm going up on the number line, I'm going to the positives. If I'm going right on the number line for the x's, okay, that's also to the positive numbers. Okay, if I'm moving down or to the left, okay, my number is going to be a negative. And that's because down on the y-axis and to the left on the x-axis are all negative numbers. Okay, so that's why we pick positive or negative, or that's how we pick positive or negative. Okay. Okay, so we're going to look at a graph here. Okay, and we're going to find the slope of each line. So the first thing that you need to do whenever you're finding the slope of a line is find 2 points that you can count off of. Okay, so I'm going to find a couple points here. There's one. Okay, I'm going to find where it crosses on my grid. Okay, there's another one down here I can use. Okay, looks like there's only 2 on this one. And then I'm going to find the slope of my line. So I'm going to figure out, okay, if I start up here and I go down and to the right, how many units that I have to go down and to the right. Okay, now you can also start here and go up and to the left, and you will get the same answer either way. Okay, so I'll show you both ways. So it's always going to be rise over run. Yep.
So how do you pick where you want to go?
I just look at where the line crosses at a place where it meets. I don't want to pick one that's just crossing through a random spot. I try to pick where it meets the actual point, not the fraction. Does that make sense? so rise over run. Okay, so if I'm starting up here at this point, okay, I'm going to go down first. And anytime I'm going down on the y-axis, I'm talking about a negative, okay, because I'm going towards the negative numbers. And I'm going to count how many units I go down. So I go 1, 2, 3, 4, 5 units down. So that's going to be a -5. And then I'm going to do my run, or I'm going to count how many units to the right I'm going to go on the x. And if I'm moving right, that's a positive. So that's 1, 2, 3, 4, 5 units to the right. Or sorry, I don't think that's enough. 1, 2, 3, 4. Okay, you can count that. Okay, so I went down 5 places, so I used the negative. I went right 4 places, so I used the positive. If I can reduce it, reduce it. Okay, if not, it stays just like that. Do not make this a mixed number. Okay, leave it as an improper fraction. Don't make it -1 1/4. Okay, now one thing I do want to show is if you would have started at this point down here and went up and then to the left, okay, you would have went up 1, 2, 3, 4, 5. So if you went up, it was a +5. Okay, and then you would have went to the left 1, 2, 3, 4. So it'd be a -4. Okay, -5 over +4 is the same thing as +5 over -4. Those two things are equal to each other. Okay, so those are the same thing. Now, for the second one here, again, I'm looking on my line, okay, to find a place where it crosses one of these grid marks, okay? So it crosses right here. There's another one right here that it crosses. I'm just following the line and looking at where it crosses, okay? Then I'm going to count my rise over run to see how I get from one to the other. Okay, so I'm going to go up, and then I'm going to go to the right. So when I'm counting my places, I'm starting here, going up 1, 2. Okay, so if I'm doing rise over run, my rise is a +2. And then I'm running to the right, 1, 2, 3, 4, 5, and that's a +5. Okay, so that's going to end up being a +2 over 5. Okay, I can't reduce that or simplify that anymore. Okay, so that's what I'm going to get there. Now, the one thing I do want to point out for this is if you would have started at this number up here or this point up here, you would have went down 2, which would have been -2, and you would have went left 5, 1, 2, 3, 4, 5. So you would have had -5. Okay, if I simplify a -2 and a -5, that does make a positive. Okay, 2 negatives makes a positive. So I do still get the same thing. Okay. Any questions about that from anybody on Zoom or anybody out here? Good. Okay, if you guys have a question, you can just unmute yourself and ask me, okay? Okay, so this formula right here, slope formula, this is definitely something that you're going to need to know, so I would definitely write this down. Okay, at home, those of you that don't have a note sheet, I would definitely write down this slope formula. It is not going away, and you're definitely going to need that. Okay, so slope is rise over run. Okay, so we're going to talk about how to find the slope if they don't give us a graph, if they just give us some points. Okay, so what this means, y2 minus y1 over x2 minus x1. I'm finding the change or the difference between the y's, and anytime I use the word difference, I'm talking about subtraction. And then I'm finding the difference in the x's, or the change in the x's. Okay, now these little numbers here, okay, like the 2 and the 1 on the x and the y, okay, that means the second y, or the second ordered pair, and the first y from the first ordered pair. Okay, the second x from the second ordered pair, the first x is from the first ordered pair. Okay, so they're going to give us some points here. Write a couple things here. And it says find the slope of the line through -1, 0, and 3, -2. Okay, so what I like to do is I like to label these. Okay, if this is my first ordered pair, x and y, okay, I'm going to label those as x1 and y1. Okay, if my second ordered pair, 3, -2, okay, x2, y2. Okay, so that helps me figure out what exactly I need to plug in up here. Okay, so here's my slope formula, y2 minus y1 over x2 minus x1. Okay, if I'm looking at my ordered pairs, I'm trying to figure out what is y2. Okay, so y2 is going to be the second y, which I've labeled as -2. and I'm subtracting y1, or the first ordered pair's y, which is 0. So negative 2 minus 0. Okay? Then I'm going to do the same thing on the bottom. Second x minus the first x, or 3 minus negative 1. Now, one big thing that happens here is it's 3 minus negative 1, not just 3 minus 1. Okay, so make sure that we pay attention to that. Okay, don't just put 3 minus 1, you're going to get the wrong thing. You're always subtracting what that is. If it happens to be a negative number, okay, 2 negatives, we should know makes a positive. Okay, keep change opposite. So now I can simplify. Negative 2 minus 0 is negative 2. 3 plus a 1 is going to just be 4. And this is actually for the first time one that I can reduce. Okay, so if you type negative 2 over 4 on Math Excel, it's going to tell you it's simple. It can be simplified, or it's right, but not all the way. Okay, so negative 2 over 4, I can simplify, divide both of those by 2, and that will give me negative 1/2 for my slope. Okay. Questions about using that slope formula? Any questions from you guys on Zoom? Okay, so another one just like this. Okay, and again, I like to label these when you're first starting out so that you can see exactly what everything is. Okay, so you have your first x and y, and you have your second x and y. And then it's really easy to see what you need to plug in where. Okay, so y2 minus y1. Okay, my second y, negative 1, minus my first y, positive 3. Okay, x2 minus x1, or 4 minus 1. Okay, did I not see where those numbers are coming from? Everybody good on finding those numbers? Okay, so negative 1 minus 3, that's going to be negative 4. 4 minus 1, that's going to be 3. Okay, negative 4 over 3 does not reduce. Okay, I can't reduce that by anything, so it's going to stay as negative 4/3. Any questions about using the slope formula or finding the slope? Okay. So last part here, talking about the slope of a horizontal line and the slope of a vertical line. So horizontal line, okay, I'll give you an example for that. It runs left to right. This is the horizontal line right here. Okay, the slope of a horizontal line is always 0. Okay, they can also call it no slope or 0 slope. Okay, so those are the things that you can use for that: 0, no slope, or 0 slope. Okay. So if they were asking you to find the slope of a horizontal line, it might look something like this. Okay, it would just look like 2 regular points. Okay, I would use my slope formula, x1 and y1, x2 and y2, and I would figure out what the slope is. So I just want you to see what this is going to look like. Okay, so y2 minus y1 over x2 minus x1 looks like this. y2 is 2. Okay, the first y is also 2. On the bottom, x2 minus x1, that's 2 and negative 3. So 2 minus negative 3. So when I go to solve this, on the top I get 0, and on the bottom I get 5. Okay. Anytime you have 0 over 5, okay, you can type that on your calculator, 0 divided by 5, that's going to simplify just to 0. Okay, so I always like to think of that as if 0 is on the top and something is on the bottom, that's okay. Okay, looks like that. Okay, if 0 is on the top, that's okay. You can have whatever you want on the bottom. As 0 is on the top, that's okay. It just simplifies to 0. Okay, now for a vertical line, okay, a couple things that they'll call the vertical line. It's undefined or it does not exist. Okay, it's undefined or it does not exist. So if I was going to use my slope formula, I'm going to label my points to start out with. Okay, I've got my second y minus the first y, so 1 minus negative 2. x2 minus x1, or negative 2 minus negative 2. Okay, I'm going to do some keep change opposite on top and bottom. Okay, up on the top I'm going to have 3, but on the bottom I'm going to have 0. Okay, now you cannot divide anything by 0. Okay, cannot divide by 0. This is not something that I can do. Okay, so this is undefined or does not exist. Anytime 0 is on the bottom, you cannot do that. If you try to type that on your calculator, it's going to say error. If you try to do 3 divided by 0, it's going to say error. Okay, so like I said, okay, when 0 is on the top, okay, this one is no. Okay, 0 is on the bottom, that's a no. 0 is on the top, that's okay. Okay, so a little thing for you to remember that. Okay, so you can put undefined there. You can put does not exist. There's also DNE as an abbreviation for that you might see sometimes. Okay. Now, that's all about slope. So that is all for the notes. You definitely need to make sure you have this formula written down right here. Okay, slope formula. You for sure need to have that. Okay, so I'll leave that up there for a second so that you guys can write that down. Okay. Are there any questions right now? Any questions from you guys? Okay, I'll put that in just a second. Okay. Okay, so what you guys are going to work on now